Okay, here we go for part 3 of SAC from Thursday. So, our next couple of questions refer to the following information. The Tower of Terror amusement ride at Dreamworld starts from rest and moves in a straight line with a uniform acceleration of 15 metres per second. Alright, uniform acceleration means we can use all of these formulas that I gave you on the first page. Okay, and this is what these next couple of questions are going to involve, just putting numbers through these formulas. So the first question, question number 13, is what is the speed of the ride 3 seconds after starting? Alright, it starts from rest, so its initial velocity is 0 metres per second. Its acceleration is 15 metres per second, and it's given us our time. 3 seconds, and what do we want to know? Alright, the final velocity at that 3 second mark.
Yeah. Am I interrupting?
Yes, you are interrupting. That's alright.
Are you recording?
Yeah, so we've got our 3 values here and our 4th value, so we just need to work out what formula is going to work. UATV. UATV, this one will do us V equals U plus AT.
Tag is awesome.
So V is what we want to know. We've got our U here, 0 plus acceleration, which is 15 times by time, which is 3. 15 times 3 is 45, plus 0 is 45. 45, and it's asking for the speed, metres per second. Alright, on the page, next question. Question 14, what distance has the ride travelled from the starting point 5 seconds after starting? So distance is our unknown. It's given us our time, that's 5 seconds. After starting, and we knew it started from rest, so that's U, metres per second, 0 metres per second. Oh, that's right, and it gave us our acceleration as well. It said the acceleration was 15 metres per second. Alright, back to our formulas. XTUA, XTUA, this will do. X equals UT plus half AT squared. We could do it this way. X equals U is 0. 0 times by T is 5 plus half 15 times by, what's our time? 5 seconds. 5 squared. Alright, 0 times 5 is 0, so that's the end of that. So we end up with half times by 15 times by 5 squared is 25. So 0.5 times by 15 times by 25 equals 187.5. And what are we finding out? X, distance, so that's metres, 187.5 metres. Question 15, what is the speed of the ride when it is 24 metres from the starting point? Okay, so they've given us the distance at 24 metres. Again, we know the acceleration is 15 metres per second per second. We know the initial speed is 0 because it's starting from rest, and it's referring from the starting point when it was stationary. And what do we want to know? Okay, the final velocity at this 24 metre mark, so that's our question mark. So we're looking for a formula with XAUV. XAUV, here's a V squared equals U squared plus 2AX. V squared is our unknown, so V squared equals U squared, which is 0 squared, plus 2 times acceleration, which is 15, times by distance, which is 24. V squared equals 0 times 0 is 0, so now we're left with these 3 numbers here. 2 times 15 with 30 times by 24 is 720. Alright, so V squared equals 720, so what we need to do is square root V squared to get V by itself. When we square root 720, we get V equals 26.8 speed meters per second. Alright, we will continue to question 16. A bungee jumper falls from a bridge. Alright, you're falling from a bridge. Your acceleration is going to be 9.8 meters per second squared. The bungee rope begins to stretch after 2.8 seconds. Okay, they're giving us a time here, so 2.8 seconds. How far does the bungee jumper fall in this time? Okay, two knowns that have been given to us. Now, the other thing we know is that if he's started from jumping off the bridge, his initial velocity is going to be 0 meters per second. There's three knowns, and our unknown is how far, so that's a distance. Okay, ATUX, ATU, no, where do we want? ATV, ATUX, X equals UT plus a half AT squared. X is our unknown. UT, initial velocity, so U is 0 times by T is 2.8 plus 1/2 times by acceleration, which is 9.8 times by time, which is 2.8, and that's squared. X equals 0 times 2.8 is 0, so we end up with, let's work backwards here, 2.8 squared times by 9.8 times by 0.5 is 38.4. That's it. X is 38.4. How far? 38.4 meters. Okay. Still talking about our bungee jumper. Now, this part of the question. Later, the stretching bungee rope brings the bungee jumper to rest from a speed of 25 meters per second in a time of 3.8 seconds. Calculate the acceleration of the bungee jumper during this time. Okay, so he's free-falled, and now the bungee cord is stretching and slowing him down. So for this part of the motion that we're analysing, he comes to rest. So his final velocity is 0 meters per second from a speed of 25 meters per second in a time of 3.8 seconds. Three knowns. Calculate the acceleration. So it's our acceleration that's the unknown. Again, VUTA, VUTA, V equals U plus AT. V, 0 meters per second. U, 25 meters per second, plus acceleration, which we don't know, times by time, which we do, is 3.8. So 0 equals 25 plus 3.8a. Subtract 25 from both sides, give us 0 minus 25 is minus 25, equals 3.8a. Divide both sides by 3.8, so we can cancel that out. So our value for a is going to be 25, negative 25, divided by 3.8 equals negative 6.6 acceleration meters per second squared. Alright, last one before... Actually, no, we'll stop it here and we'll go for one more.